My name is Brandon Gogetap, and today we will be talking about dependency injection with framework. Dagger 2 is that framework. So first, go over kind of what dependency injection as a pattern is. It's the act of providing your objects with the dependencies they will need rather than having them create or instantiate it themselves. Calling new can be expensive and wasteful, especially if you are creating new objects every time you do a repetitive action. So obviously caching is better for performance. Dependency injection allows for easier reuse of dependencies. And so here's just kind of an example of a bad data retriever class. It has a method in getWeather that takes in a string for city, and on each call it's creating an OK HTTP client, retrofit instance, and using those to build a weather service. So this is obviously not ideal, so what we would want to do is just pass in the weather service. The data retriever doesn't care about retrofit, doesn't care about the OK HTTP client. All it needs is this service to do its job. So this is dependency injection. No frameworks or libraries involved. This is just kind of how the pattern works. Downside to this is now this class looks clean, but maybe our presenters or our activities now are cluttered. So this is something we do every day. It's a required pattern to create efficient programs. Like I said, our model and library classes now look clean, but what about the call-in classes? So we go over to our hypothetical presenter in this case. We're doing the exact same thing here. We are creating new instances of the client, retrofit, service, and now the data retriever on each call to load weather. So this is pretty easy to fix. We just pull that into the constructor, pull the data retriever into the field, and so now as long as we are using the same data presenter instance, we have a nice efficient kind of presenter model combo. Everybody's happy, except for you, because you now have all this boilerplate in your presenter. And this is excluding anything else your presenter may have to handle. So it's not unreasonable to expect there's a lot of other code in this, and that can easily get out of hand. So kind of to reiterate, dependency injection as a pattern is efficient, but it just shifts boilerplate code from your model to your presenter classes, makes them cluttered, and if you want to go back and change any instances, it can be difficult. You may be using that weather service in more than one place, so you're either creating new retrofit instances and OK HTTP clients in each case, or you're passing around the same one, which can be hard to follow, hard to track down, and if you ever need to go back and change those, it can be difficult to find. So ideally, we want the instantiation of all these types of dependencies in one place that we can easily go to, and that's where frameworks come in. So they kind of do the work of passing around dependencies for you. They reduce the amount of new calls in your classes for your dependencies, and again, concentrate all those in easy to find areas. And Dagger 2 specifically is a framework developed by Google. It was forked from Dagger, which was created by Square. And you group your dependencies in classes annotated with module annotations. They're called modules in Dagger and Dagger 2. You can provide scope to these dependency graphs using components, and we'll go more into depth on that. So this is the example of a potential top-level module, and we'll go through piece by piece here. The module annotation just tells Dagger that this class is a module that's providing dependencies. The provides annotation marks a method that will provide a specific dependency. A singleton annotation is an example of one scope annotation. It's the only one you get for free. Others you have to create. You can name it whatever you want, but singleton's the only one that comes with the annotation libraries. And a scoped method will basically reuse the dependency. So if you request it once, you will call that initial creation. And if you request it again off of the same component, it will return that instance of the object. In this case, the context does not need a scope because it's actually the context is the application which we used to create this module, and that's always going to be the same instance. So you could put the singleton scope here, but it would have no effects. Here we are defining a OKHTTP client dependency, and in this case we are actually never going to use this directly in any of our classes. So another thing you can do with Dagger modules is define dependencies that other dependencies need. So in this case, we're using this client in the retrofit dependency method. And Dagger is just smart enough to know to look through the module, look through the dependency graph, and if you request a dependency as a method argument, it will find if it can provide it. If it can't, then it will throw a compile time error. So this isn't something that's going to catch you off guard at runtime. And then here we're just providing the retrofit dependency using that OKHTTP client. We could have created the OKHTTP client in the retrofit method, but if you ever want to go back and you can create more than one dependency of the same type. So if we needed another retrofit instance to handle something else, like maybe a different base URL, we could do that, but still use the same OKHTTP client. So splitting it out makes things like that easier. It makes mocking them for testing easier. So that's why that is split into its own. And then again, here's just kind of a whole module. And in summary modules, define and instantiate the dependencies that will be provided. They can only contain one scope, so you couldn't have singleton scope and then another custom scope in one module. You can mix scoped and unscoped dependencies in the same module. And the scope dependencies must match the scope of the component that uses that module. And we'll look at the components, which is the next piece of Dagger. Here's a potential component for that module, and we'll go through piece by piece again here. The component annotation tells Dagger that this is a component, and you define which modules that component uses to satisfy its dependencies. And again, here's the scope annotation that matches the annotations we used in the module. Now, to build scoped dependency graphs, there's two ways that Dagger 2 allows you to do it. This is one way where you define these methods that will take in a module that another component requires, and it will return that other component. And so in this case, if we called plus on our application component and provided a main module, we would get a main component returned. And we could use that to inject classes, and those classes would have access to all the dependencies defined in the application module and all dependencies defined in the main module. And when you're done with it, you can destroy that main component, and the next time you create it, you will get a new instance of it, which is kind of how you handle going back and forth on the screen. And we can look at that closer when we look at the demo app. These methods are used to inject classes with this component. So you have to define all classes where you manually call inject. So in this case, in the my application class, I would be calling application component.inject. And this is just another piece of Dagger 2's runtime verification. You wouldn't be able to use this method without it defined because it would just say the method doesn't exist. So it's pretty difficult to get, I might have said runtime, I meant compile time. It's pretty difficult to get runtime errors with Dagger 2. I think about the only way you can do it is somehow providing it with a null object when creating a module, and unless you specifically mark a dependency as nullable, that will throw an error at runtime. All right, so in summary, components are the glue between modules and the injected classes. They are what you use to inject classes. They allow you to manage scope. You can build the dependency graph out of only the modules and components you need. And when you're done with them, you can throw away piece by piece to allow those dependencies that you no longer need to be garbage collected, or just renewed if you're going to kind of the same screen but in a different scope. And scope dependencies will be reused if you're using the same instance of the component to inject a class. So if you have a cache component and you use it to inject an activity in onCreate, as long as you're not recreating that component in onCreate each time, you will get the same dependencies that you did before that configuration change. And here is a beautiful illustration of kind of a component and subcomponent relationship. So the main component in this case is annotated with a subcomponent annotation, and that's one of the two ways Dagger 2 allows you to build kind of these scoped graphs. It's the way I prefer. And with this, anything injected with the main component will have access to all dependencies in the application component, which gets its dependencies from the application module, and then the main component, which gets its dependencies from the main module. So there are three ways to inject dependencies with Dagger 2. There's constructor injection, field injection, and method injection. Constructor injection is something you would probably use most of the time when these are classes that you create. You have control over their constructors. And in this case, you do not have to manually call inject in the class. So if you just add a inject annotation on the constructor and pass in what dependencies you need, as long as Dagger can provide those dependencies, it will work. And if it can't, it will let you know. They're available to use right away because, like I said, you don't have to manually inject. If we look at field injection, so this is something you'd use in like fragments or activities, views where you don't have control directly over the constructor. You do have to use a component to manually inject the class, and in this case, I just have a helper class called injector that gets the typed component and calls inject. And so after that line of code, the shared preferences in this case will be available to use. Method injection is a thing. I don't have any good examples for it. I haven't heard of many good reasons for it. Dagger 1 doesn't support it as far as I know. I think I've read one use case where if you needed to provide a dependency that needed to take in the class that you're injecting as a dependency of its own, that could be a use case, but otherwise I've never used it, but it's there.
What would the other side of the constructor injection look like? Would it just be a...
It depends on like what's using the data retriever.
Right, if I was calling data retriever.new, and when we go to the parentheses.
So you would never instantiate data retriever on your own. So in this case, like if you're using it in a presenter, which actually itself is probably using constructor injection too, you would just provide it as a constructor argument, and it would just work. So in that case, you have your retriever, your presenter, which uses your retriever, and then let's say your fragment, which uses your presenter. You would do field injection for the presenter and your fragment. Right? And then to create that, it would say, I need to be able to provide this with a data retriever, and it would just kind of go down the chain.
Okay, so that's all.
So you're never, the only time you'll ever manually instantiate kind of a inject constructor dependency is maybe in tests, when you're just mocking the dependencies that it's taking in. Otherwise, yeah, it's usually just provided as a constructor argument or as a field injected somewhere else. So, Dagger 2 summary: modules provide the dependencies, the components inject the classes, and scope dependencies persist for the life of the component. So if we go back to our efficient data retriever that we had at the beginning, all we'd have to do on this is add the inject annotation. And if we go to the presenter, and this is where the good stuff happens, all we'd have to do here is add an inject annotation, pass the data retriever in as a dependency, and Dagger would just put all of it together for us. So Dagger 1 or Dagger 2, they're both great. They both have their positives and negatives, but I don't think there's a huge benefit to either. Dagger 2, probably my favorite part about it is the compile time checks. It's nearly perfect. It's very hard to get runtime errors. But because of that, it is slightly less flexible. In Dagger 1, you can inject in a superclass, and all the subclasses will get injected if they have injected fields. That does not work in Dagger 2. You have to explicitly declare which component you're using and which class you're injecting. The stack trace of errors is a little bit easier to follow in Dagger 2, but again, that's a kind of situational positive. Dagger 1 is by no means bad. Probably the hardest time I've had with Dagger 1 errors is if you're trying to inject something that that isn't being provided anywhere and doesn't have an inject annotated constructor. It'll just kind of tell you that, and it won't tell you what class is trying to inject it. But it's usually not too hard to narrow down. So either of them are great to use, and I think make building applications more fun and easier to maintain. So benefits of using dependency injection framework just overall, I think it makes maintaining code easier. Modifying dependencies much easier. You know where to find them. They are in modules. And testing, I don't know exactly how you would test without some kind of, or how you would mock, I should say. You can still test, but if you wanted to mock an OK HTTP client that you're instantiating in a presenter, I think it would be kind of difficult. You might have to write some weird code just to make that possible, whereas if you're using dependency injection, it's very easy to do, and I have some examples of that in the demo app that we'll look at. And it makes following single responsibility principle easier. So I know when I first started learning programming, which was when I first started learning Android, and I'd look at some samples on GitHub, and they had multiple packages and a few classes in each for a super simple app. I usually just backed away and said, I don't know why this is so complicated. Every tutorial I'm watching puts everything in the main activity. Why are they splitting this out so much? Luckily, I got over that pretty quick. Just making multiple classes is not, it's not going to make your app more complex. Having classes that have a specific purpose just makes it easier to maintain, even if just you don't have all, hundreds of lines of code to look through. So manually dealing with bundles, resetting up your state on config changes, I think is a pain. Dagger can help a lot with that, with persistent dependencies that survive configuration changes. And kind of going along with the multiple classes, dependency injection frameworks make passing your objects around to other helper classes a lot easier. If you make a class and decide later that it needs another dependency, you don't have to find every place that you instantiated that class and add it to the constructor argument. It's just, it makes adding things like that a lot easier. So bottom line for organization is your views, which could be fragments, Android views, or activities. should be dumb. Should delegate the handling of state to something besides your views. Your views shouldn't be doing business logic. And you should just have your views tell you what the user did and tell them what to show, and let that be that. And all this combined just makes testing and maintaining your app far easier, and dependency injection helps a whole lot with that. And that's all there. I have some links here, but we'll go through the demo app, so I can put these up later. But Jake Warden's given talks on Dagger and Dagger 2. They go a lot more in depth of how Dagger actually works. A couple libraries you can use to make managing your scoped components easier. And I'll show those. So to just kind of walk you through how it would look in a functioning application, it all kind of starts with main application. Usually you have a component that will provide dependencies through all scopes of your app. So in my case, I'm using retrofit and OK HTTP client shared preferences throughout my app, so I have it in the kind of top level module/component. Theoretically, you could put everything in this component and just have a public method on your application and easily get a reference to it and inject whatever you wanted. That's probably not very good practice because you'd have dependencies in there that you don't need for a specific screen or scope. And by building scoped components, you allow garbage collection and stuff like that to happen. So Dagger generates classes, and in this case, any class that is annotated with the component annotation, it will generate a Dagger, whatever that component class was named. It knows what modules to take in because you define them in your component here. And what I'm doing here in Get System Service is just, this is a way to intercept calls on context.getSystemService. So any class that has access to context can theoretically be injected relatively easily. This is something that's handled by libraries for you. I think I just kind of did it manually. One, because it's a good learning experience, and two, because I haven't used those libraries yet, so I didn't know how hard it would be to set up. But I assume it's easier to set up than building on your own. And so I have a class here that holds on to instances of components, so I can reuse them after configuration changes and stuff like that. And this is a dependency itself, so it's in the application module here. I could have done an inject constructor, probably should have done inject constructor, but I didn't. So the meat of this, though, really comes to the testing. And what that allows me to do is I can mock the dependencies that my fragments are using. So in this case, it's a weather app, and I don't want to have to make a call to the weather service over the internet when I'm just running tests. So by being able to mock these dependencies and telling it what to return when a method is called on my weather service makes testing much easier. I just define these mocked responses down here. And up here, I basically say when the service asks for the weather, depending, this is just kind of a different thing I have depending on what's in your shared preferences, but basically any method that's called on my service for weather, I'm going to return my mock object. And again, that just makes testing faster. You're not testing the third-party API, you're testing your application, so you don't want any outside interference to mess up your test. And we can see, so my application module for shared preferences, I'm just mocking it. And again, that allows me to any call to shared preferences. I have a property in there called last city ID. I can return whatever ID I want, so I can make the app behave the way I want for that specific test. And my component cache I'm mocking, so when it asks for a component, when my fragment asks for a component, I can give it the mock component that I created in the test. So this is the presenter for my main fragment. It's annotated with this for main annotation, which is one that I just created. And that matches up with the main component. So as long as the main component instance that I'm using to inject, in this case the fragment, is the same instance, I'm going to be getting the same instance of these dependencies, whether they're provided in the main module or they're injected like the presenter, which is constructor injected. So here I have these fields in the fragment that I'm injecting, and on view created, I'm basically checking if the component exists, and if it doesn't, I am building it. And how I did that was I pass in the bundle in case there's something we need to persist across like process death, because that's one thing your components will not survive. They'll survive all configuration changes, but if your process is killed, your app restarts, the components will obviously not be there, so they'll have to be rebuilt. But here I'm just checking the component cache. If it has an existing component, if it doesn't, I'm building one and then putting it in component cache. And I'm doing this with context. In this case, I overrode the getContext method on fragments, and I basically wrapped it in my own class that has a getTag method on it. That allows me to differentiate between fragments or any views created by those fragments with just the context. So if I go to my forecast fragment, I actually conflate a view when a day is selected. And since I am creating this view with my overridden getContext method, in this view, I can just use injector, get component. I know which component I need, so that's why it has to be typed with Dagger 2. And by passing in this context, which is an instance of that, let's go to that class, my Dagger context wrapper I called it. My injector will be able to call getTag on that context and be able to know which component or how to find the component that it needs. Forecast fragment, I have an example of how you get around process death. So to start the forecast fragment, it needs a weather response, which is the first in the list of the app that loads, and we'll look at the actual app in a second. Maybe that'll make more sense, but it does take in that piece of data from the first fragment, and so it's parcelable, which means we can save it to a bundle, and if the process gets killed, we can rebuild that from the bundle and put it into our forecast module, and then it'll be available to be provided to all classes that would care. And my big thing I like, and this isn't just Dagger, it's really just kind of architected. Okay.
That's awesome.
Well,
Presenter mode.
What's going on?
It's a new multi-screen thing.
All right. Well, we get to see how fast Google's new emulators are, which is pretty fast.
It's fun.
Anyway, about app architecture, separating your business logic from concerns of the life cycle of Android applications just makes things a whole lot easier. If you lose things on rotation, that's frustrating, but if you design in a very separate, kind of separation of concerns way, you don't have to worry about that. And I wanted to show so this, since it's a fresh launch of the app, I just have it looking up Omaha if you haven't searched for anything yet. And if I click this button, I will load from a random list of cities I have. And so you can see all the requests there in Chrome. If I rotate, there's no more requests. These are persisted in the presenter. And in the presenter, basically when the fragment says I'm attached to the presenter just calls set data and gives it the data that it already has. So you don't have to make multiple calls. If you have your service running as you're rotating, it's no big deal. It'll keep going because, again, the view, in this case fragment, is not in charge of any sort of logic like that. So it's just displaying what you tell it to. If stuff's happening in the background, it doesn't care. It holds no state. And then here, when you click, you're passing in the weather response to be able to populate the header. And if we kill this, if we terminate the application so the process is now completely killed, reopen it. Oh, hold on. I have to do it from multitask. So if you open it from the drawer, it launches. So the process was killed, but going here should theoretically go to that forecast screen. Go freeze. It worked once, but basically that's what rebuilding this does, because Android, especially if you use fragments, which I personally don't much, but Android will maintain that backstack for you. So it's important to make sure that the data is accessible if it's trying to load something that's kind of deep in your backstack and not the first screen. So you always have to be prepared for that. At least it didn't crash. Anybody have any questions or want to see something specific in the project?
I have a question. Are you injecting the constructor of all your helpers? Is that how you get around static injection? Is by injecting the constructor and then doing the...
Yeah, so basically anything you don't need control or you don't have control over constructor, you kind of have to do the manual inject. If you have control, and these are helper classes you've built, it's almost always possible and easiest to just do constructor injection.
So did you have to do anything special? Because it looked like you had a different app module for testing versus not.
Yeah, so there's a couple ways. If you look at Google's code lab, their Android testing code lab, what they did was have different flavors of their app. So you could have something, you can have a main module, but depending on the flavor you're in, it will pick from that specific directory. I went the route of just kind of creating my own and testing, and since I am in control of the component cache, which is going to give these classes the component. I just give it my mock component, which takes in the mock module. And yeah, so here I have those two mocked. Yeah, so there's a couple ways you can do it. I chose to go this way because I don't like having active code that I'm going to be using outside of the main directory. I just haven't got used to that pattern yet. So this is one way, but yeah, if you look at Google's Android testing code lab, you can kind of see another way of how to provide mock implementations of things.
So this is more for like the integration testing stuff where you just use mocks in line.
Yeah, so I do have some, so like here, testing the presenter, this is the one case where I'd manually instantiate the presenter, and I'm providing it with mocked dependencies because I'm just testing presenter logic, not these in this specific test. But yeah, you'd only really have to override the components and stuff like that in the espresso test, integration test.
What is the, in Dagger 1, what would you say the component equivalent is?
Object graph.
What?
Object graph.
Okay.
So yeah, and that's not typed, so that's, you don't have to know the type you're calling, which is inflexible, but it leads to potential runtime failures, where if you don't declare the class in the injects parameter of the module, where you say which classes it injects, it'll let you build and it'll let you run until you try to inject that class and then say you need to declare this, whereas since you need a typed component in Dagger 2 and you need to call a method on that component with your class as the parameter, it's impossible to build without declaring which classes you're injecting.
So are Dagger 1 and Dagger 2, or I should say Dagger 1 still actively maintained?
Yeah, and widely used. Square still uses it. They do have they gave a talk recently about their migration of one of their apps to Dagger 2, and to me it looked like a whole lot of work, and obviously they're getting some benefit out of it, but I would say if you're using Dagger now, I don't think there's a huge reason to switch. If you haven't used either, I wouldn't fault you for starting with Dagger. I mean, I don't think it's harder or easier than Dagger 2, but it's still going to be actively maintained. It's not like it's going to be dropped. Yeah. It's still, I'm sure, much, much more widely used than Dagger 2.
I started dependency injection recently. I started with Dagger 1 because there's more examples. There's a little more intuitive to me. I think I read somewhere that they initially wanted to name them two different things, Dagger 1 and Dagger 2, because they're still using Dagger 1. It still works and it still will work. Dagger 2 is kind of a different.
Yeah, well, Google wanted to take the kind of last remaining reflection out of Dagger, and they, Gregor Kick, one of the Java Pro Libraries guys at Google, gave a presentation on Dagger 2, and he said it improved performance like 13%, which is, I mean, it's good and it's probably amazing for Google, but it's not vital.
And they're talking server-side stuff. So
yeah.
13% is a lot when you run as many servers as Google is.
Really?
And that's Dagger 1 and Dagger 2. They're both just Java libraries. They're not anything particular to Android. So.
Yeah, Juice is the kind of the what was used before, but it was relatively slow on Android, which is what sparked the development of Dagger. I haven't looked at Juice at all, but that's kind of what's used. I'm sure it's still used quite a bit today on like server-side stuff.
So you said it is slow, Juice, compared to Dagger 2?
Comparatively, yes. So you wouldn't use, well, you could, but if you use it on like a mobile device, like an Android phone, the object graph creation stuff, that is much slower than Dagger. And that's what sparked the creation of
So
Dagger.
this is the main reason is Dagger 2.
Yeah. Well, Dagger is fast compared to Juice. Dagger 2 is a little bit faster than Dagger. They're both very good for mobile devices and I'm sure server side. I just don't. I know Juice had a couple that's a little more flexible than even Dagger, method injection and some other things, but I don't know too much about that.
It's kind of like an MVP question. Did you do models in this?
What's my model in this?
Yeah.
I would say my retriever classes, so my loader classes. But I think some even say there should be another level of separation between this and data. I think this is plenty. My presenter just expects an observable with the response. If I ever want to come back and change it, I mean, I could return this observable weather response straight from the service, my weather service implementation, which I kind of do. But if I ever wanted to change how I'm getting that, this class being an intermediary between the presenter and the service would give me that flexibility. And I'm using RxJava in case anybody was wondering why these are so concise.
Do you have the code or the slides out, like on GitHub or something?
I will tonight. Yeah, I'll put them up. The code's on GitHub. I posted a link in the meetup.
That's right, I think I saw that.
Yeah. Because I'm not good at reading. But yeah, I'll have the slides up tonight too on whatever is good.
That'd be great.
I'll post the link.
They were good.
Thank you. Yeah, I know I went a little fast and I skipped over kind of how Dagger works because Jake Warden is much better authority over that than me and he has several talks on it. So,
Are you using both Dagger 1 and Dagger 2? If you had a choice, start a new project tomorrow, which one would you use?
well, I've already done that, so I'd say Dagger 2.
That works.
Cool. Thanks.